gotta wait for the actual day. Wait, are we even gonna be in school on the actual day?
No, we're not. No, it's not.
Guys, when we come back on Friday, if we're still coming back on Friday, then we should do a belated celebration.
All right, so
That's fine. Or we can celebrate it right now. Those are two options. Minerva's birthday. Oh my god, are we in school on my birthday? I'm so excited. 8+6.
all right, so what we're gonna do is we're gonna deal with chain rule, and the chain rule is gonna be something that it's very, very important. You cannot get away with it. But I'm gonna just start talking about what's within the functions. So first of all, you understand what is composite function. A composite function is so function within the functions, right? So function within the function. So function within the function. So first of all, if I say there was a f of g of x here, and this is going to be f of g of x, and I'm going to ask you identify what is f of x and what is g of x. So what if I have 1 over x plus 1, what is my f of x and what's my g of x? 1 over x is what? Is f of x, good. And the g of x is what? X plus 1. Does that make sense? It's pretty easy, right? So you got to understand which function within which functions. That's equal to tangent. So the next one is I'm going to ask you is something, let's say sine of 3x. What will be the f of x and what will be g of x? Sine x is going to be what? Sine of x is going to be f of x. And what is, I'm sorry, sine of x. And what is g of x? 3x. Good. Okay, so that is going to be it. Now, what will be square root of x squared plus 1? What will be the f of x and what will be g of x? What is it? Which one is it? F of x? Okay, so this is square root of x and what will be g of x? Okay, good. How about the next one is gonna be the next one is gonna be 10 square of x. This one's kind of tricky though. Very good. 10 of x and the x squared. So some people thought it's 10 of x and 10 of x. But if it's 10 of x and 10 of x, you plug in the x, it's going to be 10 parentheses 10 of x. So that's not 10 square of x. So you got to make sure you understand that. So that's that. Okay, so composite function is a function within the functions. Now, why do we need to worry about this? Because today, chain rule is very focused on taking derivative of a composite function. So if I want to take a derivative of composite function, let's say d to the dx of f of g of x here. Now, it's very simple. You have to understand there are two layers. There's an outer layer and there's inner layer. So what you're going to do is take a derivative of the outer layer, multiply, and keep the inner layer still inside, and multiply by the derivative of the inner layer. So what I meant is this, it's going to be f prime of g of x times g prime of x. And that is the derivative of the chain rule. So basically, there are two layers. One is going to be this layer, and one is going to be this layer. Then it's going to be f prime of g of x, and then g prime of x. Okay, is it difficult to remember? Now book has a implicit definition of chain rule, which is I don't often use, but it's gonna look something like dy dx is equal to something. So this is a book definition in terms of implicit, which is we don't use all the time, but dy dx is equal to dy du and du over dx. That's gonna be the two things multiply each other. Okay, so let's understand that dy dx equal to dy over du and du over dx. So, but we don't use this definition a lot, so we don't have to worry about it. Why is the chain rule is very important? Because it's very effective to take a derivative. Now, what I think about when to use chain rule, right? When to use chain rule. So when to use chain rule? Usually is first is composite function. And the good thing is I'm also going to list second one, which is it still belongs to composite function. It's basically with parentheses. So with parentheses with power other than 1. Okay, so there are two situations with parentheses with power other than 1. So first is composite function. Second is parentheses with a power other than 1. Okay, so those are the things that you will require to use chain rule. Now I'm going to show you why chain rule is so effective. Because just say if I have y equal to, that says 3 minus x squared to the 10th power. Now, is this the other power than 1? Is a parenthesis other power than 1, right? It was 10. Now, of course, you can do this, expand 10 times, and do power rule. But you're going to be there forever. To expand 10 times, use Pascal triangle, it's going to be way more, right? So let's take a derivative of this. If I take a derivative of this, just imagine that this is big X. It's X to the 10th power, right? So you're going to take a derivative of the outermost. So if I say take a derivative of this is going to be 10 times 3 minus x squared to the 9th. Are we okay? And times derivative of the inside, which is people usually forget. This part is don't forget. Because on the test, people are going to forget this part because derivative of the inside. Yes?
Okay, about the test. Is that so?
No, it's not Friday because we're going to have 2 days off. Probably going to be Thursday. Tuesday, sorry. Probably going to be Tuesday. Yes.
Where did the 10 come from?
10 is this 10 right here. Usually if I do power rule of x to the 10th power, what happened to the 10? 10x to the 9, right?
Oh.
So that's what happened is 10, 3 minus x squared to the 9th power times the derivative of inner function, which is derivative 3 minus x squared is negative 2x. Okay, does that make sense?
Yes.
Okay, so it's fairly easy, right?
Wait, is that just the answer?
Well, yeah, I might want you to take a derivative of one of them here. So it'll be y equal to 3x minus 2x squared to the 3rd power. I want you to try to take a derivative of this one. It's very easy. Just try to take a derivative. So this one year I have a I have a teacher upstairs does the same thing. They just shoving the chairs. You can hear it. Like meanwhile, my kids are taking tests with shoving the chairs. They have like a music chair or something. I don't know. So I went up there, and I said, "Can you guys stop doing this?" And he said, "We're not doing anything." And they start again. I got really mad. Eventually, I was sending student 5 minutes over to her classroom, and then she told the principal that I was harassing her. I'm like, "Are you gonna be kidding me, right?" So they said, "Okay, you want to try harass? I'll teach you what to harass." So I have a student new. He's a computer programmer. As a computer programmer, and he knows how to like just dial phone calls in computers without showing like the IDs. So I have my student call her every 5 minutes, and she'll pick up the phone and there's like hello and nobody's there, and she cannot track the call. And yeah. So I was like, you know what? I'm not gonna. But that was like it happened like 6 years ago. It was funny. So we would just call her every 5 minutes. So it's okay. Nobody knows who I am.
You still have snacks, Mr. Yang? Like, do you have any more left?
Do you want some?
Oh, hey, sure.
Why is all the people hungry?
I don't know. I think it's not
It's been a long look. How is part? Your part is brain food.
Okay, so did you guys take a note of this?
Yeah.
Okay, so it'll be 3 times 3x minus 2x squared to the second. But don't forget this part, which is 3 minus 4x. Did you forget that?
No.
Okay, then that's good. So you know how to do chain rule. Now, I'm going to ask you to take a derivative of this one, though. 3 times x squared minus 1 to the square here. I want you to take a derivative of this one. Now, remember, the power rule doesn't give you the jurisdiction over radicals. But you can always convert a radical over the other way. So let's see if you know how to take a derivative of this function. So let's talk about algebra. Algebra has this rule, a to the m over n equal to a to the m. This is called definition radicals. So you can change this to rational exponents. So if that's the case, then you said, well, first of all, how do I memorize this? This is an easy way to memorize. It's like, this is a tree. The tree has roots, right? It has a brown roots, I think. Right? And it has a power. So this is a power. This is the roots. So it's always power over roots. Okay, so m over n, not n over m. Okay, does that make sense? Okay. So then you can change that. You can say y equal to x squared minus 1 to the 2 over 3. If I take a derivative of this, it's going to be 2 over 3 times x squared minus 1 to the negative 1/3. But don't forget there is a derivative inside, which is 2x. So I can simplify this, becomes 4x over 3 times x squared minus 1 to the negative 1/3. Questions?
Oh.
And if you really want, you can change this 4x to the 3 to the third roots of x squared plus x squared minus 1. So if you want to simplify back to radical, you can. Question about this part. Now, so I'm going to tell you there's 3 moments you should avoid quotient rule on your test. What are the 3 situations? So 3 situations you should avoid quotient rule. What is the 3 situation? When when the denominator is equal to 1 term, please using something called split. I call it split. So a plus b over c is equal to a over c plus b over c. You don't understand how crazy this idea is on SAT. They show up all the time. You just don't know it. They show up every single SAT. A over c, a plus b over c is equal to a over c plus b over c. Second, when denominator equal to 1 term, you can always split and take a derivative with power rule. So you can follow with a power rule. So you can follow like a power rule after. And second situation is I have denominator is a number. So for example, if you have y equal to x squared minus x over x, I can split this to x minus 1. And I can say y prime is equal to 1. And a simple things to do derivative, just split them instead of deal with quotient rule. You don't have to deal with headache. In denominator equal to number is a little bit different. So y equal to x squared minus x over 3. I can just say y is equal to 1/3 times x to the cube of x squared minus x. And I can take a derivative, just take a 1/3 in the front, and don't worry about anything else. Just take a derivative inside, which is 2x minus 1. So I don't have to do quotient rule at all. I just take the constant in the front because 1/3 is on the denominator. Okay? The third situation, which is the things that we're going to talk about today, which is the third situation, what if numerator is a number? Equal to a number. Okay, what numerator equal to a number, let's just say y equal to, which is the situation I'm going to give it to you, which is I want you to take a derivative of this. Negative 7 times 2x minus 3 to the 3rd power. Now, avoid quotient rule here. Now, here's, if you avoid, I would do with a chain rule. Okay, so you guys are going to take a derivative y equal to negative 7 over 2x minus 3 to the 3rd power. So how do I avoid quotient rule here? Can you do quotient rule? Yes. But you should avoid quotient rule whenever you have those 3 situations. When bottom's 1 term, split. When the bottom's a number, you can take out a number, do a constant multiple rule. The third thing is the numerator is equal to a number. So let's see if you guys know how to take a derivative of this. So I'm going to try to do chain rule here. So can I move this to the top? Okay, I love the positive vibe there. -7 times -3 times 2x minus 3 to the -4. Now, did you figure something? Multiply the derivative inside, right? So derivative inside is 2. So it's this one's going to be 42 over 2x minus 3 to the 4th power. So that's how you take a derivative of this. No, it's a 42 or hold on a second. 3.
It is 42.
It's not too hard, right?
Where did the -2 come from? Just
Not -2 times 2. Derivative of the derivative of this. Okay, so the next thing that we're going to talk about is how do we take a derivative of certain things. So how much time I have?
Way too much.
Okay. All right, so I have a lot of time. 9, 12. Okay, so good. I have a lot of time. So we're going to talk about a whole thing about derivative. So I'm going to talk about this particular part. Is going to be the trig chain rule. This one's it's actually pretty easy. The way I teach it, it's going to be super easy. You just have to understand how to do it. So let's just say y equal to sine to the 4th power times tangent of x squared. And that's it. We want to take a derivative of this function. Now, you probably never seen this before, but yes, it does happen. So you have to understand where the arguments is and where is the function within the function. It turns out there's a 4 layer in this function. Hopefully you can see all those 4 layers. Now, what happened is going to be y equal, I will rewrite this because I don't understand this notation as well. So I'm going to write it like this to the 4th power. If that's a 4, that means whole thing to the 4th. They are between the function and the parentheses. Does that understanding? It's not legal, it's legal. So I'm going to show you the first color. The first color is going to be, let's go with blue. This is the first layer outside. It's like x to the 4th functions, right? The second layer is going to be the purple, which is going to be here, right? The third layer is going to be the brown, which is here. The 4th layer is going to be the green, which is here. So there are 4 layers of the function. Now, when you take a derivative of this, you're going to take a derivative from the outer layer and slowly work your way in. Keep inside the same. So, y prime. I'm going to work on a blue layer. I'm going to color code for you so it makes it easier for you to understand. So let's look at the first layer. It's something to the 4th power. It's something to the 4th power, therefore it's x to the 4. How do I take the x to the 4?
4x.
Yep. So here it's going to be 4, but instead of an x, you're going to keep inside the same because inside never change. When you're peeling the onion, inside doesn't change yet until you work on the way inside. Inside stay intact. Now I'm going to take it, oops, sorry, this one should be the blue. So I'm going to color code this for you. This one should be the blue. Okay, now I'm going to take a derivative of the purple. The purple is a sine of tan of x squared. So if I take a derivative of sine of 10x squared, I don't take a derivative of everything in there. I just take a derivative of the outer layer. So derivative of outer layer is going to be purple. So what's derivative of sine?
Cosine.
Cosine. Then keep everything inside the same and not changing. Because inside is still intact. Now I'm going to go work on a fourth layer, which is the brown, which is tangent x squared. What's derivative of 10?
No.
No. No,
That's
that was
y
the
squared. Secant squared.
secant squared.
It's x squared.
See, when you learn from home, yeah, it's different. Yeah.
Secant square of x squared, and then take a derivative of x squared, which is 2x. So you can finally say the final equation is going to multiply this, 2x and 4 is going to be 8x sine of 10 of x squared to the second times cosine of 10 x squared times secant square of x squared, and that's my final answer, and that's derivative of chain rule. Now the hardest part is to change that to a when I draw the bubbles outside, inside, inside, inside. I have different color code, so make sure that it's easier for you to understand.
Wait, why did they go from to the power of 3 to the power of 2?
You're right, as a third.
You okay, Michelle?
Yeah.
Why is it secant squared x squared? Secant x squared.
What is it?
Why is it secant squared x squared? Isn't it just secant x squared?
Okay, so derivative 10 is secant square of x squared. X squared is still intact. We haven't taken derivative of x squared yet. And then we're going to multiply by the derivative of the x squared because that's the innermost layer. Does that make sense?
Sure.
Let's try one. Let's take a derivative of 10 to the 4 secant of 3x. Okay. So let's take a note of this. But before that, I'm gonna take a time to write out because I don't like this format. And I'm gonna write down to the 4th powers here. So that's gonna be 4th power. And I'm gonna write out the layers. So the first layer is gonna be red. Second layer is gonna be the blue. The third layer is gonna be the purple. The fourth layer is gonna be the brown. So let's start with the first layer. So I'm gonna say y prime is equal to the first layer is red. So I'm gonna take a derivative of the red layer, which is 4 times tangent of secant of 3x to the third. Does everybody got this part? Is okay? Okay, let's go with the blue part. What's derivative of tangent? Secant square, good. That's gonna be secant of 3x. Now, what's derivative of the secant of 3x? Yeah, but you gotta be careful where here it's gonna be the secant of 3x times tangent of 3x. Because that's inside still there. And let's take a derivative of the brown, which is 3. And that's equal to, no, that's a very common mistake. It's okay. 12 tangent of secant of 3x to the 3 times secant square of secant of 3x times secant of 3x and 10 of 3x. And 12 is in the front because 3 times 4 is 12.
Wait, go back, please. Wait, Monsieur, could you fix the screen?
Oh, that's my fault.
Or what? Finish your sentence. No, finish your sentence. Yeah, yeah.
So I just multiply the 3 to the 4 in the front becomes 12. And that's my differentiation of a trig thing. Are we okay here?
No, why is it?
Can you just explain what you were doing at the end with secant 3x tangent 3x?
Okay, so you understand the blue part, right?
Yeah.
Okay, so now I'm going to take a derivative of the secant of 3x. Remember, derivative of the secant of x is secant of x, 10 of x, right? But the problem is not x. 3x still there. So that's 3x is still intact until you take a derivative of 3x. It's going to be 3 at the end.
But you only take it once because it's only on the original function.
Yeah, only in the outer function. You only take a secant of u, for example. So it's going to be secant of u, 10 of u. And then let's take a derivative of 3x, which is 3.
No, explain the blue.
Sorry, which part?
Mm.
This part? How's the derivative of the purple part? So derivative secant of x, let's say secant of u. Don't worry about what's 3x. Derivative secant of u is going to be secant of u, 10 of u. But the problem u here is 3x. So it's going to be secant 3x, 10 of 3x. Then you're going to take a derivative of the brown part, which is the last n, which is going to be 3x. Then times derivative of 3x is 3. Does that make sense or no?
Talking about blue, not purple.
Oh, blue?
Yeah.
Okay, so what's derivative tangent of secant of 3x? What derivative tangent? Not worry about what's inside. Derivative tangent is going to be secant square.
I think I'm gonna go over the pencil and do the whole unit over again. Oh.
Okay.
Yeah.
Are we okay here? Shall I give you one more to make sure you master at the scope?
Yeah, one more.
Okay, so let's say it's y equal to, I don't know what I want to do. Let's do with tangent, not tangent, we already did tangent. Cosecant of 4 of,
It was 4.
well, we can do 8.
No, I meant more like can we do like 2 or like 3.
And 8 is fun. Okay, so cosecant of 8 of cotangent of square root of x. Now you can actually do cosecant cotangent of sine. You can do that too. Oh, actually, matter of fact, let's do that.
Wait, what?
Now there's probably 5 different layers here.
I think it's fucked up by the hurricane.
Oh, too bad. You're stuck with me.
Now just go to the beach. I'll go to the beach.
I can't swim, so it will work, y'all. That's the thing.
How can you not swim? You live in Florida.
Yeah.
Me too, actually.
Oh, you can't swim? You
Yeah.
know, my brother taught me to swim. He just started throwing me.
That's what most people do.
And I teach my son how to swim. I now don't know how to swim still.
You told me to teach you how to swim, Mr. Day. You can come to swim practice with me.
I don't know. That would be so embarrassing. Me swimming is like this. It's like a summer ring.
You can come to practice with me. We'll do so good. I'll teach you all the strokes.
Teach you how to stroke.
What's good?
I just need to be able to stay above the water.
I can teach you how to egg meter. You can come to water polo practice.
What is the 8 meter?
It's like spin your legs like tread water really fast.
Oh, yeah, I can never do that.
Yeah, but like that'll help you like stay afloat if you really.
Yeah, I just don't want to drown. That's it.
Yeah. I'll teach you how to egg
You will
meter.
be fine. Focus. Yeah, well, it's tough.
Then you won't.
It's fine. If I get a 0, so I'm in class. Exactly. So focus. Focus.
How many layers are in this?
Way too many. Wait.
It's gonna be really long. You just write out everything.
Did I forget all this? There's only 4. Where am I just blind? Yeah.
Now there's 5 layers.
Wait. Wait.
I wish I could color code this to show you, but sadly.
Wait. No, come here. What am I skipping? Like, I'm reading the same information you are. 1.
Third layer. Layer that.
Thank you.
Negative cosecant plus
See, Mr. Gay, my table leadership goes beyond borders. Cross number to other tables.
So you read there are 5 layers here.
Oh my gosh. Yeah, so good question. I think it's just negative cosecant. Negative cosecant, that's not right.
Oh my god, wait, how do I even do that? This is gonna be the longest thing ever.
Cotangent is negative cosecant squared.
Oh, bad. Wait.
I'm not losing my shit.
Wait, what? Whoa.
So let me color code this for you. So the first one is red. So this is the red.
Mr. Gay,
Uh-huh.
why are you subtracting?
It's not subtraction times -1. Let me do here that help you. And this second layer is the green, right? Sorry.
What's code on that? It's something of Quotient.
Negative cosecant.
The purple is gonna be what?
Oh, I did it.
Negative.
That's not.
Oh, hold on, I'm almost done.
He's put what, y'all?
Because the derivative of cotangent is negative cosecant. So instead of avoiding cosecant, you can do it. I'm not very sorry.
No. Wait, can you write it?
Oh my god, I finished. I've never simplified.
I'm done. I'd love to take a picture of this and fun.
So the next one is going to be cosine of square root x. And the derivative of the gray is going to be 1/2 x to the negative 1/2 will be square root x here. So those two negative signs there will become positive, so it'll be 8, something like this. So basically that's probably how much they expand like this.
And that's it.
Mm-hmm.
Oh. No, yeah,
So also we're gonna talk about generic also. Okay, so yesterday we talked about a graph, and today we're gonna come up with a graph. And this graph is gonna be something like this. I think something like this. Okay, so we're gonna say this is f of x. And let's say g of x
We can't die yet, crazy.
is square root of f of x plus 5. And I say, okay, can you find out g prime of 3? Now remember, this is a chain rule. Think about there's also something. So chain rule, don't forget. So let's learn to take a derivative of g of x right now. I will show you how to do the rest. Let's take a derivative of g of x. As of right now, it's called generic derivative. So let's focus on if you know how to take a derivative of g of x before you do g prime of 3. Now remember, there's a chain rule. What's up, Will? You look tired.
Yeah, I woke up early today.
Why?
I don't know.
You have early revival?
Huh? No. I mean, yeah. I have later.
Late arrival?
Yeah.
What did you get
Okay,
there?
so if
I went to Miss Postel to check my college essay. She said it was fantastic.
You guys take a derivative of g of x?
Yeah.
Okay. So let's see if your g of x is correct. So if I take a derivative of g of x, sorry. If I take a derivative of g of x, well, this one's 1/2 times f of x plus 5 to the negative 1/2. Did you do that?
Yeah.
Times derivative of f prime of x. Did you forget that? You did that? Okay. Now, if I want to say g prime of 3 is equal to 1/2 times f of 3 plus 5 to the negative 1/2 times f prime of 3. Are we okay here? So 1/2, this one means square root on the bottom. What's f of 3? What's f of 3? So 4 for 4 plus 5 is 9, right? Times what's f prime of 3?
It's the
No.
The slope.
Negative.
You changed the slope.
Negative 3. 4, so it'll be negative 3 over 4. Does that make sense?
That's the apple. That's the iPad.
So 2 times 3 times negative 3 over 4. So the 3 will cancel out. So it'll be negative 1 over 8.
Okay, let's see.
Where's blue and
I'm just gonna take your word for it.
No, which part you don't understand? Do you want to practice one?
No, wait. Let me finish writing
Yes.
this one. Not only just
Are we okay here? You want to practice one or no? No?
Yes. Yes. Yes.
Oh.
Yes.
Yo, let's practice.
Can we
Exactly.
take a 5-minute like break? Please.
Yeah, I see
Please. Like, please.
Can you like label it? Like the axes?
I can label it, but
'Cause I really
But I'll zoom in. Does that help you?
I'm hearing negative vibes. Okay, I'm hearing negative vibes. Stop.
Okay, so
That was negative. Someone put that up there. We're going out right now. There were a couple of tallies today that just haven't been fucking.
Nice good for
When
this.
other people are negative, it's like y'all just ignore it. But like when I make one comment, y'all are like,
Wow, bro, that.
Definitely, you gotta have like a glass half full approach. to
That's
life,
what I'm
you know what I mean?
saying.
that's what I've been saying
You
every day.
cannot let the negativity like fill you up. You know what I mean? Because then everybody else drags with you, right? And you make everybody else drag.
so many times. You've already had this speech before, yeah.
So
Dude. Root 3.
you root 3?
You guys.
Yeah, we would. Yeah.
Okay, root 3.
Calling me for like
Oh,
the
yeah.
last.
Hello, everybody.
See, our table would never have those kinds of problems.
We're in the bottom, bro.
Yeah, we are the minority.
Are you sure?
Okay, so this is the third root of f of x plus 5.
We had it.
And I want you to find g prime of 2.
And 2. You're very stupid, right?
That was the
We can
dumbest.
screen
That's the
put it on the board right now.
Yeah, literally.
Don't.
I didn't even know she was serious about it. I was kidding.
I wasn't even worried about it.
All right, come on, get the job done. Shh.
No, that's why we were working.
We are working.
It's very different. Oh, I can actually see now. Seriously, I can do it soon.
It's 2.
It's two.
Is it G of 2, Mystery, or G of 3?
G of 2. G prime of 2.
No, Max, like, what is that? It's three.
Wow.
Ah,
Also,
what is that? Max. Negative 3 over 2. It's really like just wanted me right now.
Oh. 3 over 2? Okay, close.
Oh, wow.
Negative 3 over 2.
yes.
Alright, so you're shaking your head.
Never look at it. I like to start the graph.
It's right there on the board, right there. And you know what?
It's
It's also online. Yeah. It's like constantly.
Oh, damn. That was a weird number.
I am thinking. If you did the word,
Damn.
No, we're going through it. Or like every single day.
it's fine.
No, Mr. Bean was this one.
He only knows Chris.
No, it's like here.
Eight.
Wait, it's the same answer?
They think they were trying to.
Oh, I think I might be bugging right
What
now.
did you do?
I don't know. It's possible to get the same answer. I don't know.
What? What are you talking about?
Never mind.
Like I got to this point and I don't know what to do now.
Because you were on somehow.
Yeah.
Oh, no, you're good. You just,
Never mind.
and then just plug it in.
You could say. And then.
Stop because you usually say comments like that.
There with them.
It's chicken work. I'm thinking about it.
Yeah. What did you get?
Or maybe not. It's too bad.
I did get -9.
Prime of 2 is what's it
There,
called?
but
Take your six times.
It's negative 3 over 2, right?
Because I just canceled out these four.
This is 8, right?
Yeah, it's an 8.
Answer is 2.
Oh yeah. Yeah.
I get -1 over 12.
How do you?
You still like that.
Yeah, I got the same answer. I got the same answer.
Because I
Negative
made
1 over
this.
Negative 108.
I made
Negative 1 over 8.
What?
the 1 over this, and then I multiplied, so it's 1.
2,
Do that?
2, squared, 4.
And then 2 by yourself.
Yeah.
Oh, it's 3
Oh,
now.
oh.
No,
I don't like your graphs, not your notes. You show me your work.
And then you get.
It's negative 3 over 3 times 8.
trying
2 times
That team need to work on a team collaboration.
I know, right?
Why did you leave your
What?
No.
So it makes me
So yeah, what you do, it's like, use the rule, right? So it's the third power.
Negative 108.
What's the right answer?
Negative 108.
Let's go!
I think they give it
I can actually explain this. So, wait, so, I don't know what the rules called, but you can write this round with something else. So it becomes 3 with 8 squared.
Armin or Trent, did you guys got it?
So what is the root theorem?
No,
Yeah.
Anthony, can you help out Trent and
Yeah.
Armin? And Nathan, can you help out Mia?
That 2
And Natalie, did you get it?
8.
No, you.
Okay, can you make sure your team is okay?
So that becomes 1 over 2 squared.
Look at
Got it.
Wait, can you tell me where I'm not even here?
3, 8.
I messed up
You
somewhere.
can
I
keep
just- I
it.
don't know
So
where.
now it's just
Oh, you forgot to start. Just there.
that's
Why do you
4.
4. So then times -3 over 2, the 3 cancel, so it should make 1 over
Yeah.
negative 1.
No.
I can't tell me where I canceled up here.
Natalie, your team is okay?
So this is
Your team's everybody's okay?
Oh, I hit the one at the bottom, even though I can't hear. Yeah. Okay, but we're good.
You subtracted wrong.
Wait, stop looking to the other side. Right. That's why root 3 is right here. There's only one of
Or you could just like, take a screenshot, like, take a picture,
Bro.
get it out, get it,
Wait,
get out, like,
negative two?
money looks
It's negative. Because,
yo, chill out.
because it was 1 over 3, and 1 over 3 minus 1, and negative 2 over 3.
Yeah, that's where.
Wait a minute, where does that start? Does that start with you?
We're doing great.
I'll do it.
I'm gonna get a country on this. Maybe you should learn
So I hear it's gonna be -3 over 2, so be third roots of 8 squared. So I will always do roots first.
You know how 4?
If I do root first, it's gonna give you 1 over 3 times 2 squared, which is 4, times -3 over 2.
Bro, I don't know if I brought this 2 out.
Then 3 is gonna cancel, so it'd be -1 over 8, and that's my final answer.
Yeah, that's it.
I think you canceled it too early. You gotta simplify each part.
Any question about this part? I want to talk about one last thing. This last thing is kind of hard. If you don't get it, it's not end of the world, but I want you to be able to get it. But this is algebra skill, so let's talk about algebra skill. So algebra skill, that's not taught. Not taught. T-A-U-G-H-T. Okay, so it's called factor out the most negative. So for example, x to the 4th minus x squared. We already taught this to factor out the most negative power. I hear the GCF is x squared times x squared minus 1. Does that make sense? So you can factor out the most negative. But we never taught this way, x to the 4th -4 minus x to the -2. What do we factor out here? What do you factor out? Which one? -2 or -4? -4, good. But what happens if you factor out -4? What do you have left? So remember, this is all subtracting, right? This one is a 4 minus 2 to get 2, right? And this is 2 minus 2 to get 0. So this one is subtracting. So -4 minus -4 is going to become 0. So anything the 0 power is 1. And what will be the second part? X to the which power? -2 minus -4. Because you factor out whatever. So it's going to be x to the -4 times 1 minus x squared. So it's going to be 1 minus x squared over x to the 4th. You can actually simplify this more. So you can actually learn how to factor it correctly. So usually they don't teach this in school just because student can barely handle positive exponent. Nonetheless, it's negative exponent. It gets kind of sketchy for some students. But now you guys are no longer in algebra 2. You guys are in calculus.
Okay, so you can simplify this one.
With that being said, this last part is going to be a little bit more challenging. is to be able to take a derivative of this.
The whole thing is square. You take it out, right?
Derivative of this.
What is root? Then you multiply that by this.
Okay, so we're gonna take a derivative of this, but we're gonna teach you how to simplify all the way here. So what kind of rule I'll be using here? That's the first question. So realize that before you take a derivative, you need to recognize which rule you're using. Which rule I'll be using when I take a derivative here? What is it? Yes, what else? Product and chain, good job. So technically there are two parentheses multiply each other because that's a product. Now if I want to take a derivative, that's going to give you this. So that's going to be 2x. Does that make sense? 1 minus x squared to the 1/2. Is that okay? Plus x squared times 1/2 to the 1 minus x squared to the negative 1/2 times negative 2x. People usually forget this part. Don't forget because the derivative of the inside. I do both. I do both simultaneously. What I did is, because the second one is out of power than 1. 1/2, I have to use chain rule, right? So I'm going to take a derivative of x squared. It's going to give me 2x. And then I'll take a derivative. I will leave the 1 minus x squared to the negative 1/2 alone. Then I'll keep the x squared the same. And I'll take a derivative the 1 minus x squared to the 1/2. So if I take a derivative of this, that is going to give me like this. But now I'm going to factor out GCF. The problem is identifying GCF. Also, see what you can simplify here. Do you see this 2 can simplify? So what is GCF here? In this both term, they must have what? They all have what? X, would you say? They both have X. See, this is X. This is the X, right? What else do they both have? Look at the parenthesis. One minus x squared. But which power do I factor out? Negative 1/2. Good. So now I'm going to put a bracket here. So I already take out negative 1/2. And I already take out x. So what do I have on the first term? I have just 2 left. And if I factor out negative 1/2, that means that 1/2 is going to subtract negative 1/2. So that's going to be 1 minus x squared to the 1/2 minus negative 1/2. So it becomes 1. And for the second one, it's going to be minus x squared. Why x squared? Because negative 1/2 is completely factored out. You have x squared. So then you got x times 1 minus x squared to the negative 1/2. And this one's going to be 2 times 1 minus x squared to the first minus x squared. It looks really nice because this one's 1 minus x squared to the negative 1/2. This one's just going to be 2 minus 2x squared minus x squared. So end up to be x times 2 minus 3x squared over square root of 1 minus x squared. And this is my derivative, most simplified way. I remember factor out the most negative, right? See, this one's the most negative. This is the most negative. I factor out x. Also, I factor out 1 minus x squared to the negative half. Now, this one's going to be the most difficult one. You can try one. I don't know if you have enough time. But I'll give you the answer, and that way you can check if your answer is right. So, third roots of x squared plus 4. I'll tell you the answer though. If you did it right, you should get this. So you can try to do the next one, but I'll tell you the answer. Yes.
In the second step, why is it negative x squared inside the bracket?
Why is what?
Is why?
Oh, this part here, this part right here?
Yeah, right here.
Okay, so this one's x squared, right? This is a negative sign. And this x is already factored out. So you got negative x squared because this one's completely out because we factor out 1 minus x squared to the negative half. So the only thing you have left is negative x squared. So you watch, what do you have left? Okay, so you can try the next one. Hopefully you get an answer.
Oh my god.
Now that's all the chain rule I can teach you.
You can go back up and copy down the art signature.
What?
The first problem. You can copy it down.
Sure.
Yeah, I mean, not
Yeah.
Maybe